Hello and welcome to this second data collection and pre-processing lecture in this course, Master in Artificial Intelligence. So in this lecture also we will continue to talk about how to gather relevant data from various sources, ensure their quality and pre-process it to make it more suitable for analysis and modeling. So here let's start continue a journey of cleaning and standardizing data and proper pre-processing. So one of the things we need to do is standardize data formats, basically to ensure consistency in data formats, units and representations across variables that you see here. So dates could be expressed at different data differently, like 12/31/2023, 21/12/2023, and this all needs to be standardized using ISO 8601 format of YYYMMDD. Similarly, measurement units. There are so many measurement units around the world: pounds, ounces, stones, and that again needs to get into converted into standard units. Language translations. So standardizing data formats is important in data processing. Then dealing with the outliers is another important thing. Now, what are these outliers? See, outliers are those data that are on the outer side of your curve. So what you see here illustrated are the outliers. Most of the data will fall within z plus minus 2. Anything which is close to z minus 3 minus 4 is an outlier. So outlier are extreme data, to use simple word. Now for how to deal with them, there are techniques like trimming, winsorizing and other outlier detection algorithms that we can use, and let's take a look at that. So dealing with outliers, winsorization is a technique that replaces extreme values that you saw minus z plus 3z kind of a data with less extreme value. For example, the 5% highest and lowest value can be replaced by 5% next highest and lowest values. Winsorization can help in reducing the effect of outliers on the analysis without removing the data points. Similarly, the trimming is a technique that removes the fixed percentage of data points. So remove the data point itself versus winsorization from the tails of the distribution. For example, trimming 5% from both the tails of the distribution means removing 5% highest and 5% lower data instead of reducing the effect of outliers on estimation of parameters and calculation. So trimming is removing the data, whereas winsorization is converting into closer, more normal data. The other thing that you need to do is the feature engineering that involves creating new features or transforming existing features to enhance the predictive power of modeling, and this includes encoding categorical variables, scaling and normalization, and then we get into feature extraction. So, and using creating these new features and transforming existing features, we can enhance the predictive power of modeling of data. That is what is feature engineering. Let's look at each of these techniques: encoding, scaling, and normalization, and feature extraction later in another lecture. But in this, let's talk about encoding, scaling, and normalization. So what is encoding categorical variables? So converting categorical variables into numerical representations using techniques such as what is called one-hot coding, label coding, or target coding. And we'll talk about each of these as we go forward. So is what is called encoding the categorical variable. A categorical variable is something that only categorizes. It's not a numerical, like are you a man versus women versus a child versus adult. So these are you are into certain categories. So those, and come back and read the definition and examples later on. So what are these techniques of one-hot coding, label coding, and target encoding? Let's understand what are these things. So this technique, one-hot coding, let's look at what are these techniques. So start with the one-hot coding. So if your data is categorical, especially let's say that there is 3%, triple X, triple Y, triple Z, and the marital status is single, married, and focus. And these could be your three categories, and you could have a lot of data in that. Now the question is, how do we convert it into a categorical? Because computers cannot read categorical data. They need binary or numerical values. So what you do is you convert them into combinations of single digits, 1 and 0, binary. So you make category like single, married and divorced, as you see here in the second middle of the figure, and then wherever there is a person in that category, you give 1 and then you give 0 here. And that's how you do that. And depending on number of people, you could even convert binary into numerical for data for computer to read properly. Uh, let's look at the label coding in terms of, we looked at one-hot coding. So what is label coding? Now with the label coding, you might be able to guess that this encodes labels, where label is just a category like cat or a dog. And encode just means giving them a number to represent the category. So you see here, if there are three categories like apple, broccoli and calorie, then in one hot coding, we have given numbers to them, 100, 010 and 001. And the values of those are 95, 230, 150. Where in level coding, you give the category labels like 1, 2 and 3. Simple. It's simple as that. So by giving each category a number, computer now knows how to represent them. And since computer knows how to work with numbers, it doesn't know yet how to work with the categories. And now we have looked at how to do the label coding. Rather than labeling things just as numbers, starting with 1 and then increasing each category, we will go on more to a binary style of categorizing. And you may have been thinking that if you knew what is one hot is, you know, as it relates to binary, you might be interested in knowing that. So let me provide a visualized difference between these two, as you see here below, between one hot coding and label, so that you can work out this. So as you see here, three categories: chicken, broccoli and calories. In one hot coding, there are 100, 010, binary usually, and in label coding, you give category numbers. So that's what the difference in how do you do label coding as well as one hot coding. Then there is something called target coding. Now, target coding works by converting each category into a of the categorical features. Like here you have fruits, the two parts of members of this category, apple and mango. And there what you do is you represent each of these category into the corresponding expected value. The approach to calculating the expected value will depend on the values that you're trying to predict. For regression problems, the expected value simply is the average value of the category. Say in this case, if your category is apple, the year 1 data is 80 and year 2 data is 100. Your category value here could be, expected value could be 100 plus 80 divided by 290, and you could represent apple by 90 instead of, so that could be the target value. Similarly, mango could be 50 plus 100 divided by 275. So the expected value of the category you put instead of the category name, and that starts representing the target coding. Then let's talk about scaling and normalization. Scaling numerical features into a similar range of normalizing them is basically about normalizing them for standard distribution. So scaling, we are changing the range of the distribution of the data. While normalizing, we are changing the shape of the distribution of data. So that's a major difference. Now, remember that in scaling, we are transforming the data so it is within the specific scale, like 0 to 100 or 0 to 1. Now, let's look at some of the methods of scaling. One of the common methods is what is called a simple feature scaling, where the new x is equal to x old by x max. So if your examination, all the students, one of the highest score was, percentile is the one such example. Now, if your maximum, the student who got highest is 75 out of 100, then and the x student got 50, then x will be 50 divided by 75 instead of 50 divided by 100. Then there is another method called min-max scaling, in which your x new is equal to x old minus minimum and x divided by x max minus minimum. Now, after scaling the data, we can see from the image below that the original data set has a minimum age of 19 versus a maximum 75 versus the original data. So original data you see minimum is 19, maximum is 70 and 75. And in the scales data, the minimum value is 0 and maximum is 1. So you're from 19 to 75, you're scaling to a range of 0 to 1. The shape of the distribution remains same. So the only thing changes is the scale of the data, range of the data, and the shape and other properties remain same. So now let's look at what is normalization. So normalization is a more radical transformation. The point of normalization is to change your observations so that they can be described as a normal distribution. A normal distribution, as you see here, is a typical bell curve. Now for each value in the distribution, we subtract the average or mean and then divide by the standard deviation. That starts normalizing the data. X new is equal to X old minus mean divided by sigma. Then there is another advanced technique which is called Box-Cox transformation. Is a transformation of non-normal dependent variable into a normal shape. So Box-Cox transformation is used to convert a non-normal distribution to a normal distribution. The Box-Cox transformation is named after the statistician George Box and Sir David Roxby Cox, who collaborated in 1964 paper and developed this technique. At the heart of this technique is an exponential exponent lambda, which varies from -5 to +5. All the values of lambda are considered and an optimal value of your data is selected. The optimal value is the one which results in the most approximation of the normal distribution curve. So we use this score, Box-Cox function, the stat Boxcon function, which returns a tuple value of with the normalized series as the first element, and the original data is then converted into a normalized functions, as you can see here. So having looked at how to standardize the data formats, how to normalize, how to scale the data, what do we do next? We will look at how to extract now features from such a normalized or standardized or scaled data in the next lecture. So thank you so much for watching this second data collection and pre-processing lecture. And I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question, and also download a PDF file to take a look at some of the things that I asked you to look at. Do continue to see the next lecture, and I look forward to see you again.